Yeah. Who is Go Siu Chin? Go Siu Chin. Go Siu Chin. No, just asking. You email me, right? Yeah, okay. Yeah. Close the door. Man. Everyone is here. Yeah, so welcome back. I think only have 3 more weeks left. Then we'll be off for final and then holiday. Uh, so today we will have midterm exam discussion during the tutorial time. Yeah. Do you guys prefer to do quiz next week, or you guys want to have a combined quiz in the second last week? Huh? Combine, combine, combine. So if I combine, okay, my plan is like this. So I will have start from partial ordering, okay, Hessel diagram, and then from there I will include all the questions from starting from Hessel diagram up to graph. So we will view Hessel diagram as a graph, and then we will ask question in the graph. This is my plan. So the last quiz will be like it's a bit like mock exam question, close to the exam type question. So okay, huh? All all the way from the Hessel diagram part, the partial ordering. Yeah. Huh? Offset, upper bar, lower bar, and then and so on. Okay. And then up to the graph coloring. Uh, yeah, planar graph, bipartite graph. What else? Euler path, Hamilton path. Yeah, everything can include inside the concept. Yeah. Huh? Content. I think about 3 or 4 weeks. 3 to 4 weeks. Yeah. So I think we won't have chance to test on Boolean algebra. And I think Boolean algebra I already go through the content. Maybe we will finish in 1 day. Okay. So if successfully, I think we will finish by week 14. And then week 15, we can all together do some question, and maybe you can ask some question, and maybe I go through all the chapter and then point out what's the key point and then we'll work from there. Okay. One thing I want to remind the Chinese students. So yesterday I went to an honors student seminar. Their final year project. So I asked them one question. So I asked them to explain one concept or definition. He said, I cannot explain it in English. I only know it in Chinese. So since you are only first year now, I think you should. I'm not I don't disagree that I agree that you can use Chinese material, but you should put an English material on the same side. Okay, at the start. Study both. Okay. I see some of your classmates doing like this. For example, I know Sanqing, Sanqing is doing that. Okay. So you place Chinese and English material together and then learn the English material. Okay. Can understand? All the Chinese students can understand. Can understand what I said? Okay. Otherwise, you will lose your purpose studying here. Okay. 明白吗？不用再重复啊，不用重复一会儿。Okay. So, so when you come and approach me, right? So try and learn to use the English term. Okay. If you cannot build an English sentence, it's okay, but at least learn to use the English term. For example, greatest lower bound, greatest greatest lower bound, yeah, or lowest upper bound, or upper bound or lower bound. At least this term, this professional term, mathematical term, you use English. Others, if you want to use Chinese, also up to you. But at least this term, you try to use English, and then you will learn it. Okay, faster. Okay. Any other question or not regarding last week tutorial? No? So let's recap what we did last week. Hopefully today we will finish graph and then enter trees. And stop somewhere at trees. Okay, so let's recap what we did last week. So we stopped at the Euler's formula. Okay. So what is the Euler's formula about? So we can count the number of regions and number the edges and also number of vertexes. Okay. So they are linked by one. This one better. One series or two team. This one better. Which one better? Oh, not much different. Second one. This one. Okay. Yeah, I use back this one. Okay. So let's start from a connected planar and then simple graph. So no multiple edges. Okay. So how you combine these three numbers? Number of edges, number of vertexes, and the number of region. Anyone remember how we combine these three numbers? In minus b plus 2. Okay, so last week we talked about this 2 is a special number, right? Special number for planar graph. Okay, so we will try to prove this class. I mean, just go through the proof sketch, not the whole writing out the proper proof. Okay, so how on earth you gonna prove this 2? Okay, so why these two come up? Okay, so of course, first we will start with a planar representation of U. So in your mind, you should imagine some planar graph. So for example, something like this. This is just example. So you should start with a planar representation. Okay, something like this. Okay, and what can you do is you can consider a subgraph, a sequence of subgraph of G. Okay, so okay, let me write 1, 2, so easier to think about the step. 1 and then 2, construct sequence of G. G. What should I use? Maybe use G. Yeah. So how you build this subgraph? So you can, in this case here, so you can consider like, you can start from the top one, okay? And then you can add another one. Slowly you build the whole graph. Okay. So you start from an edge and then you slowly adding one edge in. Okay. So this means that G1, so G1, so what's G1? G1 is any edge. You start with any edge of your G. And then in each step, you add one edge. Okay. You don't simply add the edge, but you add the edge that is incident. That is incident with a vertex before. Okay. In Gn minus 1. Okay. And if the edge you add is new, then you need to add another vertex in. The vertex, then this edge is not already in the subgraph before. Okay. So for example, in the example we draw here, so if you add this edge in, okay, this vertex here is already inside your previous subgraph. Okay, so you don't need to add the edges in, the vertex in. But if you try to add this blue line here, this vertex is not in the original subgraph, so you need to add the vertex in. So every time you add an edge, if the vertex of the if the other vertex of the edge is not in there, you need to add it in. Okay, if it's already in there, you just need to add the edge in. Okay, so every time you add a new edge. Okay, this is how we build. We call it skeleton, maybe skeleton. Yeah, skeleton of the edge. Can follow? Can everyone follow? So we build a sequence of subgraph. No, you can ask question if you are confused. Everyone follow or not? So far, can follow? Okay, I see some nodding head. If you are confused, you can just ask. So we start from a G, okay, we build a subgraph. Okay, in each step, we add one. Okay, so this is the G1, this whole thing is a G2, maybe this whole thing is a G3, and then G4, and then G5. Okay, so far okay. Okay, so we will prove this theorem by induction. Okay, so proof by induction. So proof by induction. So what's the base case? Okay, so base case is G1. What is G1? G1 is an edge of G. So G1s look like this. Okay. So two vertex, one edge. Okay. Because G1 is any edge of G. So what's this? So what's this R equal to what? For G1, what's R? How many region you have for this planar graph? So this graph cut the region into how many parts? One part. One part. One part, right? Because this whole thing here. Okay. R1. Okay. R is equal to 1. E is equal to 1 as well. Okay. Only one edge. V is equal to 2. So is R equals to E minus E plus 2. So it's 1 equals to 1 minus 2 plus 2. Yeah. Which is true. Okay. So base case is true. So we need to prove for inductive. If hypothesis. Okay. Suppose R equals to E minus V plus 2. Okay, maybe I write K here. Is true for GK. Okay. So inductive step to show that yeah, just remove this subset first. So I want to show that the formula is true for GK plus 1. Okay, so how you relate GK and GK plus 1? What's their difference? What's their difference? So in this step, you add one edge. Okay. So the difference is just one edge. From GK to GK plus 1, you just add another edge. Okay. So there are two cases here. So either when you add in the edge, both vertex is already in there, or you have to add a new vertex. Correct? True? Okay. So maybe I draw one diagram here. So there are two cases to consider. Okay, one case is H with X. Second case is new H with both or both existing value. Okay. So what does it mean by new edge but with new vertex? So maybe you already have a subgraph here, right? Okay. But when you add in a new one, you need to add another vertex. Okay. But new X with existing vertex means you already start with your subgraph. Okay, I label it so that you don't confuse. So here is GK, here is GK, and then the blue one together with blue one is GK plus 1. So you already have the both existing vertex, maybe like this. Okay. This is the two possible cases. Okay, right? Agree? Agree, yeah? So in the first case, do you introduce new region or not? No, right? Because because uh because here still open, right? Okay. But in the second case, do you introduce new region? Yeah, because you cut here already. Okay. Is everyone following? 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 Okay. Okay. So okay. So in this case here, okay. So, so in this case here, let's compute what's the uh number of edges in ek plus 1. Ek plus 1 is ek plus 1, right? Because you add a new edges. Agree? Yeah? How about vertex? You add a new vertex as well. Okay. How about region? Do you add any region after you adding the x? No. So it's the same as before. Okay. So in this case, what do you have? Rk plus 1 equals to k plus 1 minus vk plus 1 plus 2. So Rk plus 1 is Rk. Okay. And then how about this part? Ek plus 1, sorry, Ek plus 1 minus Vk plus 1 plus 2, right? So which is equal to Ek plus 1 minus Vk plus 1, sorry, minus 1, 2, which is equal to Ek minus Vk plus 2. Okay, but by uh by the by inductive hypothesis, this yeah, okay. So we got that and oh, should I write it the other way? Will you be confused or not? Should I write it the other way? Should I write the other way? I mean, I mean, this is like an essay problem. I put my conclusion uh, in my uh, in my introduction. There's no problem, but there's problem. But I put the conclusion in my introduction here. Okay, so let me write properly one time so that you can see it. Okay, so because this part is what we want to show. Okay, so actually we should start from RK plus 1. Okay, let me write out the full thing, then we will see. So RK plus 1 equals to RK by construction. Okay, construction because of these cases. Okay, construction means this. Okay, new edges with new vertex. We don't add a region. So RK plus 1 equals to RK. Is that okay? And then this is equal to EK minus VK plus 2 by inductive hypothesis. Okay, so because it holds when GK at the GK level, and then EK is equals to EK plus 1 minus 1, and then VK is equal to VK plus 1 minus 1 plus 2. These are also by construction. Okay. So when I say by construction is coming from here. This is now what we constructed. Okay. And then you can just do the computation EK plus 1 minus VK plus 1 plus 1 plus 2, which is equal to EK plus 1 minus VK plus 1 plus 2. Okay. And So this is what we want to show. Okay. Following. Okay. Okay. So let me get rid of this. This one just some working. So and this one better. Okay. So similarly for this part here, so what's your edges? Your edges is also ek plus 1, right? Because you add one edge, but the vertex doesn't change, right? Because this both the same vertex before. Okay, that appears in the GK before. What changed is the region. So the region was increased by 1. Okay, so you can see that the +1 here goes to the region. So if you do the computation, you still get the same result. Is it okay? Okay. Okay. Hey, no one get amazed by this proof. Or you don't understand the proof. So so you see this formula, right? This formula here actually come from this simple thing only. Just come from this simple case here. Okay, from here and then you deduce the larger graph. Right? No one buy. No one want to buy this argument. Anyone still confused? Okay, confused or not? Okay. Okay. Any question? You want to know? No. Seriously, no one get amazed. Purple one? Purple one, huh? Yeah. So we want to show that R equals to E minus V plus 2 here, hold for GK plus 1. Okay. Yeah. So what we want to show is R at K plus 1 stage is the same as E at K plus 1 stage minus V at the K plus 1 stage plus 2. Okay. So it turns out from this construction here, the sequence of subgraph, we can link the K and K plus 1 number. Okay. So the way to link it depends on which cases you look at. Okay. In this cases here, EK plus 1 is the number of previous edges plus 1, right? Because you add one edges in. And then the vertex is also new because this cases is new edge with a new vertex. But you don't change the number of region, right? Because from this example here, I think should be easy to see, but in general, how to say? In general, you should also argue that why you add one edge with a new vertex, you don't add a region. Hard to see. No, huh? Okay, you buy this. Okay. Okay, so yeah, and then you try and put this into this. Yeah, try to compute this with the hypothesis, inductive hypothesis, and then. Or you don't know how to put this together. Or which this one construction? You mean this construction? Okay, so this one, okay, so there are two cases to compute here. Okay, so we first show that it is true for this case, and then we show that it is true for this case. Okay, and then we start from this case first, and then we start from AK plus 1. Okay, but AK plus 1 we know that it's equal to RK, and we know that RK is equal to EK minus VK plus 2 by the inductive hypothesis. Okay, and then we also know that the relation between EK and EK plus 2. Okay, so we put we substitute EK as EK plus 1, minus 1. And then similarly, we do it for VK. And then we try and compute this number here. And then it turns out to be EK plus 1 minus 1 plus 2. This is only one cases. Or you also need to do the same thing for the second cases. But why is it true? You just need to see that this plus 1 here, this number here, jumps to here. Okay. You can go and try and compute. Yeah, try and compute. It's the same computation, similar computation. You can try. So do the similarly show that the goals for case 2. Okay. So yeah, this one is case 1. This one case 2, you also do the same. Okay. Hello. Sleeping already. Huh? Okay. Okay. Question or not? No. Okay. So if you want to ask. Okay, next is corollary. I won't prove it unless if you request. And let me write down. So there are 2 corollary for this. So if G is connected planar simple graph, or if it's a planar simple graph with E edges and E vertices, then E is less than equal to 3V minus 6. Okay. So if you are planar graph, simple connected one, then your E and V will satisfy this equation, inequalities here. Okay. Second corollary is if you also start with the same planar graph, okay. So let me hit this. If G is a single graph, then G has a vertex of degree not exceeding 5. Okay, so it must have a degree, a vertex of degree not more than 5. Okay, so maybe I show you how to use it. I show you how to use it. Actually, there are 3 corollary. Maybe I write down the other one first, and then we will show you how to use it. So corollary 3 is go with the same condition here. Okay, and then extra condition is no circuit plan 3 and let's talk about it. Okay, so I think how to use this is you should consider the contrapositive. Okay, I think it's most useful when you want to show the contrapositive, meaning if the edges and vertex don't satisfy this inequality here, then it is not planar. Okay, so if it doesn't have a vertex of degree not existing 5, then it is not a planar simple graph. If the edges and vertex don't satisfy this inequality here, then it is not a planar graph. Okay, so the most useful one is the contrapositive. So for example, okay, for example, I think K5 is not planar. So K5 is not. Did we show K5 is not planar before? Did we show this? Have we showed this before? So this is this graph here. Sure, this is not planar before. This thing is not planar. Have we shown this before? Oh, is it easy to see why it's not planar? Okay, let me draw some isomorphism graph here. So this is sort of question you will get. Yes. So let me move this line up here. You left with this one, and this one. So you can't really move this up, right? Then you intersect. And then you can't really move this up. You will intersect. Get intersection, non-trivial intersection. Convinced or not? Convinced. Okay. So easy one. Actually, like to be precise, okay, we can use this corollary to prove it. Okay. So what is the E in this case? E is 10. Is it 10? Yes. Okay. How about V? V is 5. Okay. So E is 5. What is 3V minus 6? 3V minus 6 is what? Huh? Is what? 9, huh? But 10 is greater than 9. So E greater than 3V minus 6. So this is false. So it is not a pentagram. Okay. So this is useful to show something is not a pentagram. So similarly, you can check this. So let me see this. So G has a vertex of degree not existing 5. Okay, this one or less than 5. Yeah. Okay. I think this one also works. So you also can use corollary too. So K5 does does or does not? Does have, right? Okay, cannot use corollary too. Okay. Let me see which one can use. Okay. I got a example for corollary 3. Corollary 3. So let's look at the bar contact graph of K33. Okay. So this one is non-planar. Shown this before. This one is what we did. It's what we discussed last week. it is this one, which I explained to you using the region one, remember? Okay. So K3 is non-planar. Last time we used the graph method to show the diagrammatic. So in this case here, we can use corollary, okay, by the contra positive of corollary tree. Okay, so what's E in this case? E is 9, right? Okay, what is V? V is 6. So 2V minus 4 is 8. 8. Okay, but 9 is greater than 8, which E is greater than 2V minus 4. Okay, so that means this is false. Okay, that means this part here is false. Right? If this part here is false, it is non-planar or it doesn't have a it has a circuit of length 3. Okay, so there are two conditions, right? So here is like if P and Q, then R. Okay, so you have to note that this graph here, okay, this graph here has no circuit of length 3 because this is bipartite, so you cannot come back. Because bipartite, you don't allow don't allow the edges to stay on the same side. So there's no K3 has no circuit of length 3. Okay, so K3 must be non-planar. Okay, so it satisfies Q, so P must be wrong. Yeah. Yeah. Very quiet. I don't know you know. Too fast. Someone asking, huh? Mm. Can you speak larger? Mm. What does it mean by this? Okay, so I'm just like split this sentence here. So if G satisfy this and G satisfy this, okay, so let me underline it. So this one is the P part, this one is the Q part. This is the N part. If P and Q, then R. Okay, yeah. So if R is not true, but Q is true, then P must be not true. Not positive. Okay. Circuit is the path that start at the same vertex and end at the same vertex. And then length 3 is got length edges. 3 edges. Yeah. Yeah. This one has the circuit. You mean this one? This one? Yeah, this one. Yeah, this one got circuit, yeah, right? Mm-hmm. And then what do you mean by fulfill the condition? Fulfill what condition? Fulfill this condition? This condition? Or you mean it is planar and then it is no circuit? Is it? Yeah, what do you want to ask? Yeah. Mm-hmm. Uh-huh.
The shape is fulfill the conditions for corollary 1 and 3.
Uh-huh.
Means that the shape is greater than the V of the shape is greater than 3, and then it also has no circuit of length 3.
And then
Actually, we think choose the third one. Also can
okay. I mean, okay. So, okay. Are you saying that what's the difference between corollary 3 applying corollary 1 and 3 then? Yeah, almost the same condition. So, okay. So only okay. So the similarity here is corollary 1 and corollary 3 is you need to have a planar simple graph first. Okay, with vertex greater than 3. Okay. One is less restrictive. Okay, as long as it is planar simple connected, then it will satisfy this condition here. But the third one, your graph need to have no circuit of length 3. Only it satisfy this. Can because this one is less restrictive. This one is more restrictive. Only with no circuit of length 3 you can use this. Okay. This one is more restrictive. This one is less restrictive. This one, as long as planar simple, then it will satisfy this. But this one, you need the graph to have no circuit of length 3. Okay. And then this one, yeah, this one also, this one, the condition here is the same as for the current. Okay. 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 Yeah. Okay. Okay, so one you can show one thing is picture up. Okay. Oh, I shouldn't go there first. Then okay. Okay. So what time is it? 4:48. Well, one proof take the lecture. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think okay. So maybe let's take a break until 4:50 and then we'll come back. What do you mean you can use? You mean you mean it doesn't satisfy this condition yet?
No, I mean, if I want to put these,
This is non-playable. Okay. If can
but
stop condition. So if you compute one is 3b minus 6.
like,
Just, but it doesn't but it agree with this condition, right? Yeah. So you cannot use this, cannot use the contrapositive. Yeah. So yeah, so it doesn't say, yeah, it doesn't say anything about this graph. You get what I mean? You get what? Yeah. So if this thing is satisfied, okay, you can't say about whether the graph is planar or not. What? Remember the propositional logic? False, true. So false can imply true. What? What? I mean, yeah, you can only use this as a contrapositive if you want to say something is non-planar.
If satisfy is core one.
K33.
Yeah.
What do you mean by satisfy?
Satisfy the core one.
What do you mean by satisfy? How to satisfy? Which satisfy what?
What does that mean? Let's three.
Oh,
It's 3 edges.
yeah, 3 edges, and then
Okay, so category 3 satisfies the power 3 and power 1. Both satisfy.
What do you mean satisfy?
Equal 9 V
Yeah.
6, so it satisfies this.
So 6 times 3 is 18. 18 minus is 12. Yeah.
Yeah.
So 9 less than, yeah. So 9 less than
12.
So you cannot say anything about the planar.
Yeah.
Yeah.
So category 3 satisfy the power 1 and power 3.
No. When we say satisfy query 1, that means we have to start with a connected planar symbol graph first. Okay. But this one is not planar.
Yeah.
So we don't say it's satisfied.
What's the length of length? What's the length?
右边
Then, yeah, just now there's one student asked. So circuit, okay, length 3, 1, 2, 3, 3 edges. Back with a same nothing and ending. Yeah.
就是它这个跟 O 它一样，就是
什么
这个一定是这个，可是这个不一定是这个。
这还是
好像刚
这一个的话，对啊，这个就是 logic 罢了。
这个啊，这样这个也是差不多一样，这个不一定是这个的。
等下再讲一次。
因为上次老师我会跟你提过那个 O 是了，我随便的。
这也是。
我们是
后面的我们的 result 不一，我们是可以等于这个，可是不一定是这个。
对呀，就是来，就是 if P then Q 嘛，对不对？你就算 Q 是 true 的，Q true 不代表 P 是 true 嘛。
对，有时候我们可以 test 到这个，可是它也是难 test 的。
没有，我们可以 test 到是因为我们是用 if 这个两个是一样的 ，if not Q then not P。
你这个可以。
呀，这个可以啊，这个是 contrapositive 嘛，对不对？然后这个是什么 ？if not Q and not R then not P or not Q。but 我已经说了 not Q 是错了嘛，这样一定是 not P 哦。
Not P and not Q, then not R.
Not P or not what? Not R and then not P or not Q。
Not R and not P, but 已经是不是对，它是那 R。
因为 not Q 是错的嘛，这样一定要 not P 哦。因为我已经讲了，它真的是 no circuit of length true， 所以这一个一定要是对的。
不要问，老师可能会出。
花了这样多时间，可能会出来。I mean，
那如果
没有啦，这样啊，
前面是错的，后边不是对的。
前面是错的，后面不是对的。
如果音拍的，
false 的话，这样这个前面一定
就必须要 P and Q，然后是
后面才是对的。
对，就是要画那个，哎，我不知道那个叫什么，
truth table。
就是哎，那叫什么来着？就是前推后也可以推前，就是 if and
啊，这个不是 if and 这个不是，这就单边吧。对 ，if 比较有用是来说它是 non-planar 了，比较有用。对啊，因为 EV 这种东西很容易算。
这个是 imply，
对，这个是有点快，一边吧。
imply 也不太好，就是前边是错的，那么我们就默认后边是对的，也不能这么说，就只能是前面两个条件都正确，才能推出后边这个条件。
对啊，当然当你要证明这句话是对的时候，你当然是要 start with 你有的东西才去证后面的 logic 的
能理解。
I mean 没有，他讲不一样的。什么？他讲的是 like if then 的 statement 这句话整句话对是为什么对？不是，他在说 他在说这整句话为什么对？
啊，
就是你当然要 start with 所有，你要 start with 你有的东西，然后你得到这个东西，这样这整句话才会对。跟刚才讨论那个，刚才我们是用它的 comparability，我们已经知道它是对的了，然后我们才来用。
最后我们会证明它，
你想证吗？还是不要了？他
不要证
们有一点昏，然后我又真又越来越昏了。
刚睡醒过的。
你想 prove 吗？
嗯，
你想 prove？
不要
对呀，
要
要，
考试会考他的证明，
不会，
不会的。
肯定不会。证明，他给我证明。
我记得上次考了证明题，我都傻了。
你会不会考的？
很多吗？
证明题，上次就是考证明定理，
还好，还好。
这考试背出来这 proof
我们一样的。
真的。
最后一个
应该是。我上课没有教，应该不会 prove 吧？
啊，对，那你
上课没有教不会 prove。
可是我觉得这个
用嘛，也至少
比较简单，
呀，
这个容易比较明白。
这个答案觉得
对啊，什么？
这里很看重
简单一点。OK，
就是它
对，希望简单一点，
跟生活
不然的话我也要被骂。
为什么学生成绩那么差？
因为你们考得这样差。
是老师没有教。
没有，他证明在书里面，书有没有很难其实，但是要有一些要用到一些东西，但是不会难。书里面有。
就什么那个？
他都干嘛一些？
那个老师他出题目他连出来简单，想帮我们的很好。
但我感觉，等下你们又不会，你们拿好成绩也是没有用。
对，
对，
通常数学老师这样。
那个符合欧拉回路的，不就符合哈利这种回路？
你是说不一定吧？不一定诶。你说 Euler circuit 啊？
Euler
你想如果它有 Euler circuit，它就有 Euler Hamilton，就有 Hamilton circuit。
那就是
啊，
不会很难。
不会啊！你看这个情况，这种题目就很像我考的那种地题那种概念题。你看这样的话，这样啊，我可以有 Euler Euler circuit。OK，如果要 Euler circuit，我再加多一条咯。但是不是很什么？
这是 Euler circuit，
但是没有 Euler Hamilton circuit。对不对？
还没，但是要一次。
哦，喂，等一下
，Euler circuit 不就是
OK，我在想的。
用手说
对。然后再给我想一个。对啊，这个
它
看嘛，
它
看
Euler circuit，
对，Euler circuit。好，可以呀，Hamilton circuit。
Euler circuit，
那你就赚到它2次了。
有它两份。
好像这题我们的 tutorial 里面就有了。哎，不是我们 lecture 的 example 就有。不是就是有一题，我们已经有一题lecture 的是。
所以他们的
应该两
个整或一个点。
是
可以
的。
对。
考试测一下。反正会直接拿出来。
啊，可以。
以。
Planar representation 吗？那是 by definition。
我直接画着一个来，我拉那个线出来，然后会 intersect。
Planar representation，我在班上不是也是这样说。
对老师不行。
不 planar 的话就有几种方法哦，就是我用那个图的每一个情况都要解释，或者就用这个，就用这些，就用这个，就 check condition on degree 哦。OK 啊。
degree 5。
And you prove what you prove, so you prove. Yeah, so you prove. Okay. Okay, I think one of your friend classmate asked a quite interesting concept question. So if you is SWE class. So if G has an Euler circuit, then G has a Newton circuit. Is this true or false? False? Why false? True or false? True or false? False? Why? Who said false? Why false? Who said false? Why? Why is it false? Why is it false? Someone said false. Why false? Why? Hello? No one to explain, but shoot the gun. I think we discussed this as a one lecture example, so you can look at this graph here. Okay, so you can find the Euler path. Okay, Euler path, but you can see that this path has to always intersect the middle point path. So this is not. You cannot find an Euler circuit. Okay. And then the other classmate asked about how to show. I think it's good that you guys start thinking this kind of question. Okay? Because this kind of question is like what I will do in the exam. How to show a graph non-planar. Okay. So a few ways to do it. So one way is to show it diagrammatically. Okay. So meaning that you cannot find the planar representation. Okay. Remember last time I do one. Let me straight away bring you back to the. So let me straight away go back to that. Yeah, this one. Okay. So you need to show for all the possibility that you cannot avoid edge crossing. Okay, this one is diagrammatic. So it's not diagrammatic, how? Okay. This is exactly the point I introduced the corollary just now. Okay. So the degree of your vertex, the number of edges and the number of vertex can help you check whether your graph is non-planar. Okay. If the number of edge and vertex doesn't satisfy this condition, but it's connected and simple, then it is not planar. Okay, use the contrapositive of this statement here. Okay, use the contrapositive of the segment. You can check that it is not planar. Of course, you need to start with a connected one. Okay, don't start with the graph something like this. Then this will violate the corollary. Okay, so you need to satisfy this one, satisfy this one, and then don't satisfy the necessary condition here, then it's not planar. Can understand or not? Understand? Okay, let me write down. Or use the positive tree Okay, so get your E and then get your V, okay, and then check this. Okay. Okay. If this is satisfied, you still don't know, you still can't check whether it's planar or not, right? Because false implies true is still true. Okay. Only when this is false, then you can say that it is non-planar. Okay. Huh? I mean, false meaning it is not less than equal to. It has to be connected, simple, but this is false, then it is not planar. Right. Okay. Okay. Or do you need me explain how to get this is non-planar again? Do you want to explain this again? How to see that this is non-planar? Or you are okay with it? Do you need to explain one more time how to use covariance here? Huh? Yes or no? Yes, okay. Okay, someone say yes. Okay, I explain again. So let me remove it. Should I remove it? Okay, I remove it and then I rewrite it. Okay. So the strategy is like this, okay? Try break this corollary into some logical statement. So it is equivalent to if P and Q, then R. Okay. So what's P? P is G is a connected planar simple graph. Okay, with this extra condition. What's Q? Q is no circuit of length 3. Okay. So P and Q, then R. Okay. Now the strategy is if not R, then not P and Q. Okay. So if I have not R, then I must have not P and Q. What is not P and Q? De Morgan's law. Not P or not Q. Okay. So if not Q is false, then not P has to be true. So this part is the non-planar part. We want this to be true. Okay. Okay. So what does it mean by not Q is false? That means Q is true. So that means it has no circuit of length 3. Okay. So let's check K33 here. So is it not R true? Is not R true? E is greater than 2V minus 4. So not R is true. Okay. So that means we got not P or not Q. But not Q is false because Q is true. So we must have not P. Yeah. Okay. Yeah. Following. Okay. Not following, you still can ask. Here you clear. Okay. Yeah. So far so good. Okay. 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 Next. So next we will talk about subgraph and homeomorphism first before we go into the graph coloring. Did it disappear again? Okay, let me see how much we need to go off first. Yeah, I think we can get to 3 a little bit. Okay, So next, let's go to elementary division. Okay. Okay, so this one a bit close to all this stuff. Okay, so what's the elementary subdivision? Okay, yeah. So elementary subdivision meaning we can cut the edges into more edges. Okay, cut more edges, and then we can cut into more edges. Okay, elementary subdivision. So an elementary subdivision of a planar graph is done by removing an edge, okay, and adding a new vertex together to the edge. UW and WB. Okay. So what you can think of is you got an edge and then you can keep adding vertex. Okay. So in this case here, we will say that graph G1 and G2. This is some new concept. You need to and accept it. So two graphs are homomorphic, or you can think of isomorphic, but this one isomorphic in a unique way. Yeah, in a unique way where they can be obtained from the same graph by a sequence of elementary subdivision. Okay, maybe I give you some example here. So last time, so for example, this one here, okay, this is not isomorphic to the square, right? Because one got 3 vertex and then the other one got 4 vertex. But they are homomorphic. How should I put the sign? What sign for it? How about put this sign here? Okay, one line. Okay. But okay, this one is isomorphic. But they are homomorphic. Are they homomorphic? Let me see. They can obtain from the same graph, right? Okay, yeah. They are homomorphic. Okay, because what you can do is you add 1, you cut this vertex into 2. Okay? Then you get this square here. Okay? So actually, all the cycle more than or n greater than 3, they are all homomorphic. Okay, understand? Homomorphic. Okay. Okay. So let me. So why we introduce this? Because this is another way to check whether your graph is planar or not. So let's see how to use this concept here. Share a nice picture from the. Okay, so you can see these are the homeomorphic graph because they are obtained from G1 by just cutting the edges. Okay, you cut and cut more, even more. Okay. So this one theorem says that Toski, I think it's a Japanese, if I'm not wrong. So he said that if a graph is non-planar, okay, this one is very strong, okay, because this is an if and only if. Okay, you don't need to count, the number of edges, don't need to count the vertex. Okay, as long as you can find, as long as this graph contains a subgraph that is homeomorphic, homeomorphic to K33 or K5. Okay. Remember what's K33? The complete bipartite graph between three points. Right? The one, the first thing we show is non-planar. And then K5 is the complete cycle graph of 5 vertexes. Just now we just showed you that it is not planar using the corollary. So it turns out that all the other non-planar graphs actually build up using these two graphs. Okay, if and only if. If it is not planar, it must contain these two. If it contains these two, the whole graph must be not planar. Okay, so that means any non-planar graph you can see, they must contain a subgraph that is homeomorphic to this K33 and K5. Okay. So let's see some example here. So this example here. Okay. So from here, you should see that this graph is not planar. Okay, because it contains a subgraph that is homeomorphic to this one is what? K5. Okay, because K5 is hiding inside this graph here. Okay, although you see that here got extra vertex, but we only care about homeomorphic. Okay, so we can like remove this vertex because they are homeomorphic. How about this one here? Okay, this one here, from here maybe it's harder to see. Right, so you need to move it a bit, okay, so that you can see that actually this graph here, this K33 graph here is hiding inside this graph. Okay, so you can try and move this vertex around and then reduce the vertex. Okay, and then you can see that this graph is hiding inside here. So yeah. Don't ask me how to see. This is like yeah. Okay, actually one way you can see that is whether you got this property or not. You can see these degree 3 properties at the vertex or not. And then they are connected by nine vertex. If they are connected in this way, then you can. It also depends on like how you cut it, right? Yeah. So sometimes it's easy to see. For example, this one. Sometimes it could be harder to see. Okay. So moral of the story is all the non-planar graph is built up using K55 or K3, K33 or both. Okay. All the planar graph. Yeah. Okay. So this is the end of the story of planar graph. Okay. Okay, next part, we will go into the graph coloring. Graph coloring is What time is this? Okay, I was thinking if we just straight away use this because not much writing. Okay, let's see. I just straight away use the slide. I don't write. Let's see. We just use the slide. Okay, because the next one is just a lot of bunch of definition. So what is graph coloring? Graph coloring is give you a map. Okay, I'll give you a map. So your job is to color this region. Okay, but with no two adjacent region with the same color. So that means if you put red here you cannot put red. Okay, here you need to put different color here. Okay, and then adjacent one you need to put a different color. Okay, so how many different color you need to color a map? So this is the graph coloring question here. Okay, so it turns out that to answer this, okay, you can string this part into a dot, and then string this part into a dot, string this part into a dot. Okay, the dual graph that we mentioned last time, the bridge problem. So we string the length into a dot. Okay, contract into a dot become the vertex, and then the boundary here become an edge. So if they share a boundary, then you will draw one edge. Okay, then this will become a coloring of vertex of the graph. I get it? Get it how to go from here to here? Okay, so the length become a dot. Okay, one color become a dot, and then you join them if they share a boundary. E and A got a boundary line. E and A have no boundary, so E and A is not connected. Okay, if they share a boundary, you draw a line. Share a boundary, so it is dual. So it is dual because you like make this can you see like a horizontal line become a vertical line? Can you see this? This one. Okay. Can see or not? Can see? Cannot? Cannot? Cannot. I see someone like this. Okay, then like this. So you make the length, contract the length into a point. Okay, and then you join the point whenever they share a boundary. Okay. So this curve here, this graph here actually is this graph. Can see it? Here. Okay. So graph coloring become a coloring of vertex. Remember the bipartite graph? Okay. Yeah. Recall the bipartite graph. We want the color to be different between adjacent vertex. This one is a higher level question. You want all the adjacent with different color. No, not to say higher level, but bipartite is just I'll say two color is enough. Okay, but here, if it is not bipartite, how many color do you need? This is the question. Okay, can you understand the question or not? Can you understand the question? Then we continue, because this is the main key question you want to answer. Okay, so what's the least number that you require to color adjacent vertex with different color? Okay, everyone got the question? Got the question? Okay. So for example, you see the graph here, no, the map here. This is the world map. Okay, can you see how many color they need to color adjacent country with different color? Can you count how many color you need? This is the world map. 4. Wow, your eyesight very good. 1, 2, 3, 4. Yes. So then keep repeating. 5. Because this yellow, this blue, okay. actually, why got 6? Where is 6? Black? Why black? No, black is the name. Okay. Actually, 4 is enough. Yeah, 4 is enough. This extra color. Yeah. Okay. Later we will see why 4 is enough. Okay. Yeah. So okay. So just now we already say about coloring of simple graph. Okay, so is we put color on each vertex. Okay, sometimes you'll see COL or R, and sometimes you see COL or UR. So one is a British, one is American. But I prefer British because I study British English. But the textbook is American. So sometimes when I copy the American. But anyway, so coloring of a simple graph is just coloring of each vertex. Okay, you just give a vertex so that no two adjacent vertex are assigned with the same color. Okay, so we don't allow something like this. Okay, so this is not a coloring of vertex. So we want the coloring of vertex as different color. Okay, so only different color is allowed for coloring a simple graph. Because if you color the same, it's very hard to see the boundary, right? Okay, if you color differently, then only different region appears, right? Okay, so this one makes sense, right? Okay, if you color all the same, then like no point. You need to look at the boundary also. Okay, next. So next we define what the chromatic number is. Okay, so we define what's the chromatic number. So the chromatic number is exactly the number we are looking for. It's the least number to color the graph. Okay, color the graph with no two adjacent vertex with the same color. So this is called a chromatic number. So chromatic number will answer our question. What's the least number you need? Okay. And then it turns out that someone proved this theorem. Okay. The 4-color theorem. Okay. So the 4-color theorem says that the chromatic number of a planar graph is no greater than 4. Okay. You can use 4 or less than 4 number to color a planar graph. Planar graph this means no edge for Seng. Okay. Just how we learn whole lecture what the planar graph is. Okay. No more than 4. Okay. So this one is important, and I need to tell you this one is important. Surely come out in the exam. So how to find a chromatic number of a given graph? Okay, how to find it? So so one way to show is you need to show that this graph can be colored by k colors and then cannot be more than k. So you need to show that it is less than equal to k, and then you need to show that it is equals to k. Okay, this is the 2 steps you need to show. 1, you need to show that it is less than equal to k. 2, you need to show that it is equal to k. Okay, which means it is not less than k. First, you show that you need to color with k color and then not less than k, which is equal to. Yeah, I will show you example. Don't worry. Okay. So, for example, if I give you 2 simple curves here, okay. So you try and start coloring, right? Okay. So you give A one color, and then the adjacent one you put different color. The one you put different color. So since this point is C is adjacent to B, C and B has to be in different color. Okay, and then D have to be different from B and C, and then you keep going. Okay. So you found that there's only you can color this graph with 1, 2, 3 colors. Okay. But if less than 3, then there will be we will have we'll have some adjacent number with the same color, right? Okay, makes sense. Okay. Similarly for H, okay. So adjacent put different color, okay. Adjacent put different color, and then you found out that actually the chromatic number is 4. Okay, cannot be less than 4 because if you remove one of the color, then there will be 2 adjacent vertex will have the same color. Okay, can follow? Can follow? 1 is to find it, 2 is to prove it. Okay, to prove it, just say that why it must be that many of color. Okay. No question or not? Or too fast? Wait for you. No? Okay. Okay, next one is Kn. So what's Kn? Kn is the complete graph. What is complete graph? Huh? So it's like 1, 1, 2, and then 1, 2, 3, 4, 5, 3, 4, and then 1, 2, 3, 4, 5. Okay. Is it obvious to see that y chromatic number of complete graph is n? You want to say something? Partial answer also can. Maybe say why you need at least n. Based on the property of this graph here. Okay, because adjacent must be different color. Okay. If adjacent must be different color, but every vertex get attached to all the vertex. So this one have to be different than this. Then this one have to be different than 2 of these. And then this one have to be different than 3 of these. Okay. So every edges got connected. So you need at least n. Okay. And then why is it equal to n? Because complete graph. Complete graph meaning like this one is K1, this is K2, this one is K3, this one is K4. So n is the vertex of the graph, and then K means you need to join all the vertex in the graph. Join all the vertexes. Okay. What? Can follow that? Right. K n is greater than n because all the vertexes are adjacent. Okay, I think I will get content again. No, is it? So maybe now let me put this one. Okay. It will be less than greater or equal to 5 because all the vertexes are adjacent to each other. So why is it less than equal to n? Because n is enough to color both. Okay, because N is enough to give this a different color. Okay. Some of you okay. I don't know the rest. The rest not following. Okay. Okay. Please ask. Just ask stupid questions also. Yeah, stupid questions also. Okay. How about bipartite graph? Okay. So bipartite graph very clear because one is on one side, one is on the other side, V1 and V2. So you can color V1 with one color and then V2 will be other color. This is what we established last time. Okay, the third one is the cycle. Okay, so cycle, what cycle? Remember what cycle is? So cycle we start with 3. And C4 is like this. C5 is the one, and then C6, C7 and so on. Okay. So for C3, if you label the first vertex as yellow, then second will be red, and then the third one has to be other color. How about C4? C4, maybe you start with yellow and then red, and then after red, you still can put yellow, right? Because there's no connection between these two. Okay, so maybe we put yellow first because we want the least one. We don't want to introduce too many colors first. And then after yellow, we can put back the red one. And then we come back to yellow. Okay. How about 5? So 5, we start with yellow and then red, and then yellow and then red. But this one can't be yellow, right? And can't be red either. So we have to put the number. Yeah. So you can show that the chromatic number of Cn is 2 if it is even. Okay. And then 3 if n is odd. Okay. Exactly because the edges here. Okay. Okay. Following. You should generalize this argument for general and positive and even. Okay. 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 If that's okay, then I think we won't introduce new algorithm yet, but we will introduce a bunch of definition for trees today. Okay, so maybe you ask, what's the application of a graph coloring other than map? So the application is scheduling the final exam. So that you won't have 2 exams happening at the same time. Okay, so if you are connecting to 4 exams, right? So you color your exam in different color. So you put the same color on one day, then you won't have a jam. So, what? Views, or you mean views? Okay, maybe let me finish application first, then we can talk about views. So yeah, scheduling final exam. So yeah, so if same color, you can put on the same days. Different color, put on different days. So if there is one day the school put the same, you got 2 exams happening at the same time, you should ask them to use this graph coloring. Okay. So next. Okay, you say wheel, huh? Wheels and cube. Okay. What is the chromatic number? The impromptu test. And wheel is X. Okay, actually I don't know the answer. So maybe we can figure out together. Like this. I'm not sure there's a formula for them or not. Okay. Let us try out. Wheel. Okay, let's try some small example and then see if we can generalize it. or there's no generalization. Sure. Okay, for example, wheels. Okay. So how many color you need? So maybe you put white at once and then put this one green. So these two are connected. They must be different. So maybe you put this, but this is connected. You need to put another color. So chromatic number of 1, 2, 3, 4. This is wheel 3 is 4. Because if you put less, then you will have a adjacent to be the same. Okay. So this one is greater than 4. Okay, this one means less than equal to 4. Okay. But W3 is greater than equal to 4 because 3 coloring, 3 colors are not enough to produce a ring. Okay. How about W4? Oh, let's try. So W4, you need to put green here. And then if you put green here, then this one must be yellow. If you put these two green, this one still can white, still can be white, right? Because this white don't connect to it. So this one can be green. Okay, this one reduced already. So this one 1, 2, 3. 1, 2, 3. 3, right? Okay, so similarly, you can deduce that U4 is equal to 3. Similarly, we say that similar means you need to go through this argument here, okay? Similarly, is 3. How about 5 here? So if you put this as green, so the middle one have to be yellow, right? So this one we still can put white because there's no connection between the white. Then this one we can put green as well. Okay, we can reuse the green. So when we find this one, we try to reuse the color as much as possible. If we put this yellow, this green, this white, we cannot put this white. So we have to put something red. Okay, so chi is equal to what? Phi is equal to 4. Okay, let's try one more and then I will try conjecture something. So let us try the 6th one. After we do this, then I will conjecture something. The one, so I can put yellow, white in the first one, green in the second one, blue, white, yellow in the middle one, and then white, then green, and then white, and green. Okay, good, very good. Okay, I will try to conjecture. So this one is 3. So my conjecture is, remember what's conjecture? Is the thing that you think that is true, but you haven't prove it. So the conjecture is chi of Wn is equal to 4 if n is odd. Greater than 3. And is 3 if n greater than 3 is even. Okay, try and prove this. Okay, so this is conjecture. Okay, based on the calculation, and then we think there's some pattern happening. Okay, we conjecture the things. If this is proof, then this will become a theorem or proposition. So the cute one, I will leave it to you. Okay. pick one, you leave it with. So I'll use this method to check. Okay. Oh shit. We haven't gone to 3. Okay, let me do 3 slides and then we stop. Okay, 3 more slides. Okay, we talk about trees. Okay, what is trees? What is tree for you? Coconut trees, banana trees. Okay, yes, very good. Those are trees. Okay. So why those are trees? Because the leaf won't grow back to the stem. Okay. So that means there's no circuit in your graph. Okay. The tree, you don't see the leaf go back to the stem, right? Okay. So tree is a connected, undirected graph with no simple circuit. Okay, no circuit. There's no circuit. You cannot grow back. Okay. So this is trees. Okay, this look like trees or not? There's a root here. Okay. So this is not a tree. Okay, no circuit. Don't want circuit. Okay, trees. Okay, you should keep any trees in your mind. Okay, next. So one easy theorem. Okay, although it's like theorem, but it's an easy one. An undirected graph is a tree if and only if there exists one simple path between any two vertices. You can find the proof in the textbook. Okay, so if it is a tree, then any two vertex you can find a simple path. Okay, so you cannot repeat edges. There's a simple path between two. Okay, because they are connected. Okay, this is a theorem. You can check it. Okay, next we want to play around with the tree. Okay, how we play around? So a rooted trees. Okay, first of all, it's a tree. Okay, one is we call a vertex as a root. Okay, and then when we take out this root, then you can think of this tree like fall down. Right? Okay, so what do I mean by that? So let's start with this graph here. Okay, if I say I want to take b as a root, so you try and take this b and then take it up, and then everything fall down. Okay, directed away. So you can see that if you take b out, then e will fall to the left of b, and then a will directed away from b, and then c, d. Okay. For example, okay, let's say we take c. Okay, we take the c out. Okay, leave it out, and then all the other points were directed away from the c. So how far away is depend on how many length away from the root. Okay, you see E is the furthest away from C because it is length 2. Okay, can follow? Can follow? Okay, rooted 3. Okay, again, next. From here, rooted 3, then you can think of this. This is your grandpa. This is your mother. Okay, of course, this one cannot your father lah. Cannot go from the same parent, right? Okay. Okay. So this one your grandpa, your father. So this one you. Okay, your siblings. Okay. Okay, these are exactly the word we're going to use to label the root. So suppose you got a root tree. So the top guy, the ancestor here, or the Adam, Adam is the first guy, is it? Okay, depend on what you believe. Okay, so this ancestor, this root here, okay, if it is not a root, then we call that appearance of a V if there's a vertex, unique vertex that link from V to U. So for example, what's the parents of D? Okay, the unique one linked to D is C, and C is not the root, so C is the parent of D. How about this? What's the parent of E? Well, the parent of E is B. Parent of A is also B because they come from the same parent. So when we say that B is a parent of E, then E is a child of B. Okay. So if you are connected at below, you are called a child. And then E and A is are siblings. Okay, because they are on the same level, right? And then coming from a same parent. And these are siblings. Okay. So what's ancestor? Okay. Everyone know what ancestor means? Or your yeah, right. Good. Yes, very good. So your father, your grandpa, your great grandparent. Okay, so what's ancestor means? Okay, for example, ancestor of E, okay, is B and also C. Okay, all the way to the start. You need to include. Of course, you are not your own ancestor, right? Okay. It will be funny. So, okay, ancestor. Okay, how about descendants? Okay, descendants is everyone below you. Okay. So for example, what's the descendant of C? So it's B, E, A. Okay. Those that has you as the ancestor. See, D? D, yeah. D is what? D is a sibling of B. D is not descendant. Oh, D is yeah, right. D is a descendant. Yeah, correct. Okay. Okay. I forgot D because yeah, right. D is a descendant. Okay, good, very good. Okay, then next one we call a leaf. Okay, which one we call a leaf? Those that doesn't have a child we call a leaf. Okay. Yeah, it's the one that is outermost. Okay, we call a leaf, right? Make sense? Leaf. Okay. And then what else? Okay, vertexes that have a child is called inner vertex. Okay, this one very important. Inner vertex. So you are either a leaf or you are either an internal vertex. Okay. So if you are not a leaf, you must have child. So these are all the inner vertex. So that means inner vertex and leaf partition your vertex set. Right? You can't be leaf and inner vertex at the same time. You cannot have child and no child at the same time, right? So either, yeah. So they partition your set. Okay, since I talk about it, so let us put a remark here. So leaves internal vertexes partition. Okay. So next is okay, subtree, subgraph. Okay, what's the subtree is? So so if A is a vertex in your tree, okay, a subtree with A as a root is the subgraph of the trees of A with its descendant. Okay. And all the descendant is equal to this descendant. Okay, so what's this long sentence about? So it should agree to what you think about it. Okay. So what's the subgraph subtree of this rooted tree here? So for example, here is a subtree. Okay, here is also a subtree. So all the edges that is all the edges is on. All the descendants, okay, and all the edges that are incident to the descendants. So the subtree rooted FD is just D. The subtree rooted FC is the whole thing. Subtree rooted FD is the BEN. Okay. Okay, maybe this example is too small. Do you need another example or you understand what the subtree is? So you need to start from a root and then all the descendants you need to include. Start at the root, all the descendants you need to include. Start at the root, you need to include all the descendants. Okay? Start with B. D, huh? So it's just D. Yeah. Yes. Yeah. That's fine. That's fine. That's fine. Yeah, that's fine. Because it's a graph. Yeah. That's fine. That's fine. A leaf can be, yeah, a leaf is a tree. A leaf is a subtree. Okay, theorem. A leaf is a subtree. Yeah. New theorem. By Zheng Chuan's theorem. Zheng Qian. Okay. Yeah. Okay. Yeah, maybe look at this example and then we'll stop. So we have a root at C, okay? And then ancestor of E is all the things that is above E. Okay, parent of E and A is B. Okay, E and A are siblings because they have the same parents. And then E and A are both child of B because it's a unique one that connect to B. And then the bottom one here is a descendant of C. Okay. And then E, A, D are leaves. And then B, C are the internal vertexes. Okay. Sub-tree rooted at B looks like this, right? Because all the descendant and all the edges that is incident of the descendant. Okay. And then next week we'll deal with some algorithm. And let me see. 9, 10, 11, 12, 13, 14. 14. Okay, maybe we'll take longer in graph because Boolean algebra maybe just take 1 hour and a bit. Okay. Any question? Any question? Yeah. You mean tree or subtree? Subtree. Subtree. Wait. Okay, you say you mean subtree. What is a subtree rooted at C? Okay, so at C you need to start with C and then all the descendant you need to include. So that's mean subtree rooted at C, that's mean from C and then you grow. Huh? No, only C is just a vertex. It's just an internal vertex, nothing. It's not a subtree. If you want to talk about subtree, you need to start from a vertex and then grow downwards. Or you mean like this, right? You mean like this? Cannot. This is not a subtree. This is a subgraph, but not a subtree. A subgraph, but not a subtree. So subtree have to be subgraph and include all the descendants. Then you grow all the way down. Subgraph can only contain C, yeah? Yeah, can. Yeah, subgraph can only contain C. Yes, vertex. Okay. So it's like you drop an ink. So you drop an ink from C, and then this ink will follow these edges. So whoever get the ink is in the subtree. Okay. Subtree. Okay, then next week we will deal with some algorithm of trees. This week just introduction to trees. Okay. Okay, so we will break for 10 minutes, come back at 6:11. So meanwhile, oh, attendance, sorry, I forget the attendance. Yeah, someone to remind me. Let me pause it. So meanwhile, one by one, you can come and get your exam paper one by one. Then you can take photos of your exam paper and then return to me after the class like a quiz.这个是哎，这不是我们，因为他这样，你这个吗？哦，一个，我记你。这是谁？哎，是吧？就这个来，那挺高的，两个一定会拿到的。来，这是九，啊，好的，看到。不是，正七，等下37，哦，237，250，每题都是10分，250这个不能，每题本身都是10分，对吧？哎，好吧，
不好意思，我错。
最后3个，265，
每
什么叫满分？
不是每道题的分数。
哦，等一下，我一找，等一下我一找，答是你啊，谁？还有谁？
我的，
好，你的 OK 好 OK，因为不见掉我就麻烦了。20，你看23，OK，这样。23，哎，去。233，对，好，你的，你的，哎呀，这个989，还有靠近你们的数字，你们可以直接翻上来。下一个，其实他是谁？98是谁？OK，8。67，他在哪里？他弄错了。Go。
2012。那强的。251。No, what's the 224？有没有人拿
608。
224？
然后最后找
对，
拜拜，
走了哈 ，OK， 拜拜，再时间。啊，找到了，
我拿得出来。
好奇妙。
我们来，然后这是我是 IS，那想一下，就定为。
是我们首先啊，
OK， 拜拜。
谢老师啊
OK， 拜
拜。
听听吧。啊？
有一个尖叫的你不是？
想啊，笑死我了！我们来个电影啊，还没电话。
围着以前一个中学，也是两个人包在中间。
你的室友是在 Kelvin 是不是？你的室友叫什么？
我室友。
有没有加你名字啊？
谁说？
拜拜。
你给加试试不对？加试试。TUC。我要查
先在哪里？
给你。00912。
OK，
340。
的话讲。
哎，给先。
就是 Ryan 的那个舒服还是你那个里面的来讲？
但是我呢还是要对吧？宝宝。
别跑，你那个是比较合适的。谢谢 Ryan 来查我们的盾。
790。110点的。对，第二三个。236。哎，你弟弟呢？哎，可以。
怎样？
找一下我那个
哪个？
是
MBT。
他呢？杨玉涵呢？
对，
没有，杨玉涵在哪？
我是让。
哦，杨玉涵 OK。
啊，我这个 24画这个是
你说放65跟24进去，
啊，对，-65和24，对，也是60，最后答案是一样。
怎么算呢？这个你是怎么算的？
你的哎，你的
你自己的？OK，你这个是怎么算的？
-8和3跟答案-8、3是一样的。我的这是一样的，放里边。
难道说
我只是往上面提倍数，这是最小的。
难道说减87减57减57乘455加21乘235，这东西是零啊？不然的话不可能会这样。
21乘上这区乘
哇，你怎么找到这个数字？怎么找？
就是先移项移成这样的，因为 m 和 n 都是integer，所以你要找一个东西等于455，然后再通过这个做一次运算，把这个 n 找到，然后 n 找到之后再回去再对的。
OK， 哎，等一下，现在还是等一下？现在还是等一下？我等一下要讨论一下。你要现在改分还是等一下？
现在改。
现在改。哎，不要紧张，不要紧张，不要紧张，等一下等我讨论完先，等我讨论完先，等我讨论完先，然后再来改分。可以开灯哦，其实开灯啊，他们看不到。
216
你签谱啊？
啊，刘谦
谱 ，OK， 给我。只是5分。这是一题。什么50个？哦，等一下，等我讨论完，再一次过来 ，OK？ 有记一下。OK， 好，刘谦谱的第8题。是你吗？我去改错了，是你啊，对吗？对吗？对吧？
对，不是啊，对，定是我。
第80吧。哦，对，OK， 好，我讨论一下。Okay, let's discuss the exam and then see you can get more marks or not. You can claim for me later. Okay. 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 So remember to sign your attendance list as well. Okay. So for first question here. Okay. So first small question. So this is not a proposition because this is a command. Yeah, it's a command, so it's not a proposition. So what a lot of you did is you think that if then, so it's a proposition. Okay, but inside the then is a command. This is not a proposition. Okay, this is a command. So it's not a proposition, so it is true. Okay. And a lot of you don't explain your step So I already wrote here, a step without, or answer without a step will not given any point. Okay. So there's 3 points for true or false. So you need to expand. Okay. It's not 1 point question. Question 2, if you change the order of quantifier, they don't always give the same true value. Okay, you can give a counter example here. Or some of you, I think quite good, you remember the example from the tutorial question. So you put the tutorial question answer in. They are quite good, I think. Again, you can remember the tutorial question. And then 3, you take the union of the empty set. Okay, so a lot of you think that this is true, false, right? We did a lot of time this one, empty set. So empty set is not equal to a set containing empty set. So empty set has no element. So when you take union, there's nothing get union in. Okay, so this is false. Okay. And then 4, the flow function is injective. Okay, it's not injective because there's 2 numbers that get sent to the same number. It's not injective. And then 5 actually we discussed about it in class, but we discussed about the contrapositive of this statement, which means if A divides BC, then B divide A divide B or A divide C. Okay, this one also false. So contrapositive is also false. So you can see that 6 doesn't divide 3, 6 doesn't divide 2, but 6 divide the product. Okay, I think quite good. Some of you got it for this question. Any question on question 1 before we proceed? No? Okay, so we proceed to question 2. Okay, I think question 2, quite a lot of you got it. It's just a truth table. Okay. Truth table for tautology, you need to show that all the true value of the compound proposition is true. Okay, need to be true. And then B, to show that this a proposition implies the contrapositive is a tautology. So a few ways you can use truth table, or you can use algebra. Okay, two ways you can show it. I think most of you got these 2 parts here, 15 marks. Okay. And then C, I said that use B to show. So I restrict the way to show this. Okay, you have to use part B to show. So which you need to use the algebra method to show. That's why I give you the table in the end. That's where I want you to use it. Okay. So how to show it? So you need to somehow see this in this form first. Okay. So you need to take P implies Q as your S, R as your T. And then this part you need to show that this is a not T implies not X. Okay. Then you can show that it's a tautology. So I give about 5 marks here, so about 5 steps you can finish the task. Okay. So that this part is actually not R implies not P implies Q. This is originally what I thought I want you to do. Okay. Any question? Any question before I proceed? Or any part you want me to repeat? Or you want to see? Any part you want me to repeat again or not? You need to ask me clearly before you can ask for marks. You need to tell me why you got marks if I miss your marks. Okay? Any question? Okay. Proceed. Continue. Okay, question 3. So question 3, why I group these 2 questions together? Because these 2 questions can use induction proof to prove. Okay. So induction proof, you need to start with a base case, inductive hypothesis, and inductive step. Okay, actually during the exam, Qianpu point out one point here. So when H0 is what? Okay, H0 because it's undefined. So actually we thought of it as H0 equal to 0. So you start from n equals to 1. And then you will go through the hypothesis, inductive hypothesis, and then show it for inductive state. And for question 2, how to show using inductive proof. So you start from n equals to 0. So when n equals 0, there's no elements here. Sorry, I mean, how to say? Okay, so when n equals to 0, the set is 0 elements. So how many subset is just empty set itself? 2 to the power 0 is what? Is 1. So it's the empty set itself. Okay. So why has suddenly like go? Turn off the aircon. Too hot. And open the door a bit hot. Can open the door? Okay. I have no oxygen. Okay. So okay, 3A. 3A is what? Okay, yeah. So we want to show that it's a proof that a set with n elements has exactly 2n, right? So what you need to notice is when you add an extra element in, okay, there are 2 subsets you need to consider. One are the subset that doesn't contain the extra element, and then the other is contain the extra element. So how you build all the subset that contain the extra element? You just put your extra element into the old subset. Okay. So by inductive hypothesis, you got 2 to the power n subset. And then if you add your new element into all the 2 power n subset, you will get all the subset. Okay, so it's 2 to the power n plus 2 to the power n. Okay. I get it on. I will put out this solution afterwards. It turns out that both of these questions, you also can no need to go through induction proof. Some of you did it. Okay. You don't need to go through induction proof also. Okay. So how you do for 3.1? You just compute this formula for all n. Just do the computation for all n. Also works. Okay. How about this one? You don't use induction proof. Okay, what you use? You use the counting. But that time we haven't learned counting yet. So what you do is how many ways one element can be present in the subset. So every element can be either in the subset or not in the subset. So there are 2 possibilities. So 2 to the power n possibilities. Yeah. So this is using the counting ways. Some of you don't use induction proof. This one also I said. Okay, 2 to the power n, right? Okay. Question 4a here. Question 4a here, I wrote something scientific proposition, but I don't need to, you don't need to understand what is this. Okay. What you need to see is, you see that this one repeat here, this one repeat here, but contradicts become does not contradict. Okay. So what I want here is actually C implies X. Okay. C implies X, and then not C implies not X. Okay. So these 2 has no relation, so you cannot deduce. You cannot deduce the inverse from the proposition. Okay, so it's not valid. Some of you break this sentence too fine. So meaning you put like S implies P or Q, something like that. Okay, too fine. No need to go into that fine. Because I already give you the hint here. Okay, just regard the whole thing as one proposition. I already give hint here. Okay. And then 2, surprisingly, a lot of you got 2. Okay. So some of the games are RPG games, but doesn't imply all the game is the RPG game. So you cannot deduce any favorite game is a RPG game. This one, a lot of you got it. I think most of you got it for this one. Okay. I think this one is better. Okay, keep going. Just feel free to stop me if you need to. Okay, for question 5 also. Okay, I just wrote some extra thing here, but actually you don't need to care about this thing. You also don't need to understand what I'm talking about it here. You just need to directly translate my sentence. Okay, I think we gave a similar expression like for all, for every. Okay, given. If you go back to my lecture notes, okay, so given here is for all. For all real number, okay, I give you a name number here. Call it an epsilon. So epsilon is a real number that is greater than 0. Okay, and then similarly, there exists another real number greater than 0. Okay, such that if blah 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 blah, then blah 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 blah. Okay, so if then implication. Okay, if this number here less than some number, then some number will be less than another number. Okay, this is what I want you to do. No need to understand what the whole thing is, but try to break it into a logical operator or symbols. Okay, and then provide negation of this statement here. So if you wrote this down, okay, then the De Morgan's law for the quantifier will be easy to see, because you negate the whole thing. So negate the whole thing become, for all become there is, okay, and then there is become for all, and then P, not P implies Q become what? P and not Q. Okay. Any question? Don't just take photo. Ask question. No question? No? Keep going. Okay, can understand? Need bigger a bit. Okay. Can understand? Oh, wait a bit. Keep going. Okay. Okay, next, 6 set theory. Find A intersection B. Okay, I think this one fairly easy. Most of you got it. 2, take the union. Some of you repeat the elements. Okay, so 2, 3, 7 is already in there, but you still put it in. So this is not a multi-set, so you cannot have repeat elements. Okay, this is just set. Okay, so don't repeat your elements. 3, a lot of you did a mistake. You forgot the empty set. Remember, the first thing we saw is empty set and the whole set is always in the subset of the set. And then some of you forget to put this set notation around this singleton here. Okay, so you don't put this singleton here. Don't put this set notation. Okay, some of you. Okay. And then 4. 4, I think a lot of you forget what's the meaning of Cartesian product. So Cartesian product is an ordered pair where the first coordinate is coming from the first set and then second coordinate coming from the second set. So if you pair up like this, it's just the cardinality of A times cardinality of PB. Okay. If you don't know how to compute the cardinality of PB here, this is the question of 3A. Okay. Okay. A set with a 3-element set has exactly 2 to the power n subset. Okay. I give formula in my answer. In the questions. Okay. And understand? So I hide the hint inside the question. Okay. So far, okay. Others? Okay. Keep going. Keep going. Okay. Okay. Question 7a. Yeah. Okay. This one I put that I purposely put this proof question one. So because this proof question, right? Actually, I think I gave in the lecture. Sorry. I gave in the lecture, but I didn't prove it. But none of you come and ask how to do. Or is this question I think stick with you for a few weeks. Prove that any strictly increasing function is 1-to-1. Okay. So how to prove this? So by definition, a function is 1-to-1 if fx equal to fy, then x equal to y. Okay, this is the definition. But to prove it, we use the contrapositive. If x is not equal to y, then fx is not equal to fy. Okay, so if x not equal to y, we still can't directly use the property of strictly increasing. Okay, because strictly increasing means if x greater than y, then fx greater than fy. So how to go from x not equal to y to x greater than y? So if x is not equal to y, either x greater than y or y greater than x. Just pick one. Okay, the other one is a symmetry argument. Then since fx is increasing, fx is less than fy if x less than y, which means fx is not equal to fy. So done. Can follow? Can follow? Okay. Okay. You should ask. Don't just believe what I say. You should ask me. Yeah. Okay. 2a. 2a, I ask you to show that it's injective, and I give you this hint here. Okay. So this hint here is to help you to show that this function here is strictly increasing, and then by 7a1, any strictly increasing function is 1-to-1. Okay. This is the logic I present to you in the lecture. How to show something is 1-to-1 if you cannot directly show it. Okay. 7a2 here, I put a bomb here. I bomb myself. I thought this function is surjective, but actually it's not. Based on my domain and codomain I pick. So yeah, so this function is not surjective. Because if you pick the codomain as if you take y equals to 1, then you'll see that the pre-image doesn't exist. So I cannot hit all the codomain. Yeah, actually I wanted to pick one codomain where it is surjective. It's easy to see, but somehow I picked the wrong one, so it's not surjective. Yeah. So it's not surjective. Because if you look at y equals to 1, there's no pre-image. This pre-image, yeah. This x equal to 1 minus 1 is not in the domain. Okay, understand? So it's injective but not surjective based on the domain I pick. Yeah. I just remember to fix for the increasing. Forget to fix for the surjective. So it's not surjective, it turns out. Okay, next. Okay, this one I think most of you got it. Okay, this one, question 8a, most of you got it. Use the Euclidean algorithm and then extended Euclidean algorithm. If you don't get it, you probably almost will fail the course. Okay, because this one is the most doable question in the exam. So if you take about 30 and below, although I can help you to pass your midterm, but I don't think you can pass the course if you continue your performance. You should really do well in the quizzes and the final if you get 30 and beyond. Otherwise, I cannot help you. Okay. I mean 30 and below for my exam. Later, I'll tell you how much we scale the exam. Okay, so 8A should be okay because more of you can do it. 9A here. 9A. 9A. 9A1 here. So you need to analyze this based on 17. Okay. This is a multiple of 17. You guys forgot you put 3. 3 times 17 is 51. But mod 17 is just 0. Okay. Remainder is just 0. But you put 3 there, so you confuse yourself. And then 18 to the power n is just mod all the 18 by 17. Okay. And then this one here, you need to use Fermat theorem. That's why this 16 come out. And then 2. Be careful when you use the Fermat theorem. You need to make sure your number is co-prime to your prime. But I didn't give that condition here. I didn't say that GCD of n and 35 is 1 or 5 or 7 is 1. Okay. So you cannot straight away use AP minus 1 is congruent to 1 mod P. What you should use is AP congruent to A mod P. Okay. The result is the same. You'll get 0. Okay. So most of you use this, but you don't have the condition. AP, quantity of AP is 1. Okay. Any question? Please ask me now. Later, don't come out and ask me. Later only can ask one out. Don't ask me about question. Please ask now so that everyone can know. Any question for this? Okay, you can think about it first, and then we will come back if we need. We will come back if we need. Let's complete the final part first. Okay. So this Chinese remainder theorem. Okay. Most of you did mistake when you try to find capital MI bar. Okay. So when you find these 2, 3, this 3 here, you just take 20 mod 3 and then 15 mod 4 and then 12 mod 5. Okay. This number here is actually the inverse of 20 mod 3. So you need to take this number, multiply with 20, and then get congruence 1 mod 3. Okay. So it's not just 20 mod 3. This A is not 20 mod 3, but the inverse of 20 mod 3. Okay. And then some of you, you don't use Chinese remainder theorem. You just test my number, 200 to 250. So you test all the 50 numbers. Okay. So that one is my mistake. My range too small. And that's what I think. I'm not sure it's your class or not. Then he just put 226. No step ones. I don't know how you get the number. Maybe the angel tell you it's 226. They just put a 226. I don't know where you get a number, so I cannot give you now. Any question you want to ask for question 10? Yeah. So in this midterm, I scale like this. So your marks times 0.7 and then add 30s. Okay. So I stack out your marks by 30s. Okay. So this like I give that all the marks that I try to trap you. So in the end, what you get is those above 80 or above 78 will get pushed to 4.0. Okay. Yeah, will get pushed to 4.0. And then everyone, I think at least will get lift out 1 grade. Yeah, this is what the scaling will do. Okay. Yeah, but like what I said, if you are 30 and below, you will most probably fail the course if you keep the same attitude. 30 and below in my before scaling, if you get 30 and below, you'll probably fail the course. It will be not dangerous. Okay. So any question you want me to go through? Want me to explain again? To go through again? Any question you want me to go through? Explain again? Please ask now. Don't later come out and ask me. Later got a lot of people want. Any question you want me to go through again? You got problem you want to go through? Any questions? No? If not, please take photos of your own exam paper because I need them back because the exam board needed the physical one. And I also need the physical one to change your marks. And then I think I will put out this afterwards today evening. Okay. Any question? Any question? Last question. Last question before you can come ask for marks or you can go or you can do tutorial. Yeah, because already almost time. Any question? Last question. Last question. No? Okay, no, okay. Okay, when you come back and return this mark, right? Please help me arrange according to number. Okay, yeah. Yeah. Please help me come put back according to number. Okay. Thank you. 啊？
一起讲评分，因为我收发到这边都对，是我们这边就忘记给他加一个60
啊，对。
然后我就想问这一题讲评分啊，一起分。
哦，对，因为你这三个都不是 inverse 啊，所以你这3分是没有啊。所以你看，我是这样子，对，对，这个是1分。哎，钟，你可以不要问，应该很多人要问这个东西。
我记
没有，你给我问我讲评分吗？
哦
OK，所以你看这个是这个1分，帮我排一下，谢谢你们。帮我排一下。说 M capital M1 1分 ，M2 1分 ，M3 1分 ，inverse 1分。
哎，这边有啊，
那你 inverse 错啊。
哪一个有吗？
I mean，你不是你找你这个不是 inverse 来啊，你这个直接拿20来 mod 3。
其实我不太记得这个东西啊，
所以你要找它的
不
inverse。
是里面我不记得这个。
对，你要找
一样啊，
不一样，
不一样。
你要找这个这个 MI 8是这样找啊，不是直接 MI 拿来 mod 一下就可以了。
是一样可以找到答案。
没有找不到了，就刚刚好这题的算法是一样的，是哪边刚刚好算到一样啊。就是找不到，不一定找得到。
OK。
也
对了，
什么
第三个不算
3分哦。然后最后这个呢？最后这个我没有给你分，是因为你没有把你的166变成这个里面。
然后我忘记可以加一个60了。
对，如果你把它变进来，我还可以再给你。
这个为什么只有3分？
这个为什么只有3分呢？你中间那么全，
当时想是只要
你这样子的话，我当然知道它全部是 T 2，因为是我叫你 proof 的嘛。但是你没有步骤，我就不知道为什么它全部都对。你知道吗？就没有步骤。
对，因为我看这个很我想很不够写，但只需要
不够写，你也不可能一个都不写，对吧？
那这个是怎样评的？就是10分那个
10分就你全部有写出来就10分了，他们全部都写出来。没有，你这个4个根本就没有步。OK， 你这个没有步骤，你知道为什么吗？你这个步骤只是啊，对啊，对，你这里只是把所有的可能性写出来。第二，你告诉我你知道什么是主 因为全部都要是
我感觉中间这个很明显，要不要写那些东西？
不可能会很明显的。
老师能把考试题发一份在 Moodle 里？
有啊，我刚才说有，
已经发了。
没有，我回去会发。
不是你那个题是连着答案一起发的。
对。
这个的。
可是你要改分就今天了。啊，
这个我不懂是为什么不对，我看那个答案
OK
是这个里面第一个是个
啊，对，这个是其中一个，
为什么？
这是其中一个点。哦，其实我可以，
这个是一
这
样的，
个我可以，
然后这个是一样，这个
对，
是这样。
为什么是这样？
哪一节？
这个嘛，对不对？
哦，要把它变成那个形式啊。
对，这个本来是这个嘛，对不对？然后你猫跟说的话就，我写错东西嘛，应该是 not P and Q，所以才变成P and Q。哎，哦，这个
5分还是4分
4分，它总共有4分。我觉得 actually 我可以再给你1分，因为你这一部分，
这个也是对的。
对你这一部分对，然后这一部分对，然后这一部分对，可以再给你1分。啊，这里错，还有这里错，可以给你2分，可以再加1分。还有吗？这样我是不是？
这个5分，
对，
然后只有1分呢，但这个是对的，这个是对的，然后这个的确是0。
没有，我没有说这个是对的，这是错的，因为你要用 N5，记得我刚才说吗？不可以用那个 AP 检验，要用 AP，因为我们不知道 N 和5和7是不是 co-prime。这个1分只是说
答案不是0末35。
答案是0末35，但是不是这样算出来的。如果你放弃其他题目做的话，它不一定算得出一样的。所以1分只是一个，不是因为你做对，是因为你至少还知道，你可以把它猜出来。OK，全部人都是这样。OK，1分了，来243的。海月157。
老师，我这个第2个问题第一个列，但是没给我分，就是不写了，但是没给我分。
Sorry, I wrote the first one. 但是你这个哪里有分？
但是你刚对了呀。
我没有对啊，我只是划掉啊。
你这个划掉了。
对，我划掉了，是错了。
不对吗？
那你告诉我哪里对啊？
就我只是把它们分开来了。
OK，好。那你在干嘛？
我在先脑地想它这个，然后就是简略一点写，就是你全都列出来的话，就是很费工的。
你就算简略，然后我也看不出这2个什么关系啊？为什么可以简到这么简？
真的是这样。
我知道。
对。
所以为什么 M 是这个嘛？
对啊。
N 是这个嘛？为什么这个 force 这个 true 这个 true 呢？为什么有一个 force true 或者 true force 或者等等的呢？对啊。
我是想，如果是这个对的话，然后再
然后你怎么知道这个错，那整个就对了呢？怎么知道呢？
有可能。
对啊。
下一页，
好，下一个，你去哪题？
我看一下那个
是，OK。
就这样。
好，这样了。OK。好，
我觉得不止一分。
啊，对，你干了什么事呢？哦，你这个是对的，这个对的，
这个是错的。
这是错了，应该可以给他，可以再加一分。
至少上80了。
你上80？恭喜！其实79也是85分。还有吗？
没有
没有了。你是506。
MEC 不是 DMT。
MEC 是什么科 ？Mechanical 啊？哦，为什么是 M 呢？
这个就是
啊，OK，好，
Marine 是吧？
好，对，
谢谢。
我当指示吧，这题，然后我抄漏题，然后这个其二在后面，然后你两个都看到打分，但前面分没
用一个我看一下，
这里是4分，
对，
我这里是4分
，OK，
但是总的在7这里，
哦
而且我只抄漏题，
，OK，
这个我写的是把后面，就是我这里写了一个，我把后面再是写，
我知道，8是10分，好像我没有算错，8是10，哦，OK，没有查一下有没有算错，我的应该可以，OK，所以是就这样就算错吧，对，还有加分的地方，就这里刚刚9，没有，我告诉你，就是7加第7，对，4分8分，OK，
老师太不仁慈了，
什么太不仁慈？
我写了1页半意思，只是给了1分。
等一下拿来给我看一下，什么？
我这里为什么7分？
太多分了，这满分是7分吗？
10分，不好意思。
为什么我拿的满分？没有啊，你没有在回答问题啊，你没有告诉我他是 valid 不 valid 啊？
这个，我天呐，这个我也不会。
他就算
OK，就算你没有回答问题，
对，就是这样证明他 valid 不 valid，就是我没有去答他到底 valid 不 valid，就是这过程嘛，你 valid 不 valid 只是一个结论，这个是我的过程。
我知道，这是你的过程，我看一下你的过程啊。好吧，可以给你1分。哎，我这边写什么？我不是写1分吗？这个是1.74，我给你2分啊，我给了，给你1分啊，2分。
好 ，OK，
1分。
好，
对
了，
为什么你不答啊？
我没注意
啊？
我没注意看，
你没注意看
对，然后我就写了。
？OK，
好
不过你还很厉害啊，还会记得这种名字。
我背了好长时
对
间。
啊，这个为什么打过？因为你没有写，你用什么 low？
我写了，这
啊，就2个可以用完，用给4个。
这不都
啊，好吧。然后你在干嘛呢？然后
1分都没有打过。
OK，你在干嘛？你在
就是从这个推到这个。
哦，你现在的意思是说，你是说你用这个，你 P 跟 Q 这个 then P implies Q is a total，就是你用的东西是不是？你看，你用它是这个，然后你就，但是这个我们在班上没有证明过。
但是我觉得证明过程有问题吗？
没有问题啊，你就证了这个东西。 但是这一个去这个我们没有证过，
所以这个，
能用
所以这个
不敢用。
所以这个1分都没有。但是我看他们的就是也量下来的，或多或少都给分了。
对，
我来这里面课，就是我的下一
那他这个几分啊？
哦天啊，
我这个没有分，
那加1分吧。但这太不公平了，会把他们证找出来那1分扣掉。
是什么东西啊？
他拿了4分。
我看扣掉，虽然扣掉，他怎么有4分啊？
什么呀？
还有4分，我看一下，我看一下，我看一下。不会扣了，不会看给我看一下吧，我要看一下吧。我不会扣
哪题啊？哪题？
我给出去就不会扣了，就算我改错。
哪题啊？
看一下。啊，他用 Part B 啊？没有啊，他做的是对的东西啊，他直接他是
我这是那
看一
个
下你的，
because 这
没有这个你是用这个，你没有用 Part B 对不对？
我用了 because 这 B， 这不是 B 证出来这个，然后
啊，你混了那个概念，这个跟这个不一样，就是这一个 OK， 你混一个概念就是你把这个当做这个，这2句话不是 if and only if， 只有这一个方向吧，你不可以说有了这个方向你就有这个，你概念混了。
所以他那个 part B 是
Part B 是只有这句话吧，他没有这个。但是这一个我们知道，是因为我们上课上过，
对
呀，所以不用紧。我可以给，我现在在想要给1分2分，
不人道，太不人道。这么多给
没有，我可以给2分，我不可以给多过1半，因为这个东西我们没有证过。
就可以了。
但是这个是对的，但是从后面推去前面是错的，所以你不可以直接讲这个东西，这个东西是错的。I mean， 这东西是对的，但是
没有证过。
没有证过，但是在这个情况我们上课上过，所以是对的。但是 in general 的话，只有前面可以推去后面，这后面去前面有一个刚才有2分 ，OK， 还有吗？
还有一个，
还有啊，
我不明白这个，
你不明白
这个，它是这道题是按嘛？
哦，这一题哈，你刚才我解释的时候听不明白，不明白。
而且记他名字，
记名字没有用，要用对。OK， 我的题目是这个 ，C implies X， 给你 not C imply not X， 这东西是不可能的嘛？记得吗？
我也这样写
啊，
答案推错了。
因为你只可以用 not X imply not C 吧，不可以 not C imply not X， 这两者没关系。
因为它定义律的问题。
对啊。
我跟
好了，看好了嘛？
对，还有这个我是不是得1分？
我这上面写的是，
你是说错还是对？
这个我就得了1分，但是你话都骂分了。
你是对的吗？这还是错误。
为什么给半分？
对了，为什么我给你半分呢？哦，可能看漏了这个东西，因为很多人只写了这个东西，没写这个东西。知道吗？这7不是？
哦，7。
OK。加216，216 17，然后第6题是4。哎，
我们同样的问题。
你看同样的问题呀，没有，你跟他不一样问题。你在干嘛？叫你证这个我叫你证这一个4个 tautology。OK。然后你只是在这旁边干了一些事情，所以你应该是这样子的。OK。然后就
对，
所以就是要2篇就同时开始写。
不是，你知道你要证
竞赛，然后
我不是这个推是这个。
你也学着
不是你要证这整个东西是一个
就是你学竞赛是全天学，但是不全天学。
不要怎么
有的学校
啊要怎么做哈？所以要怎么做？
刚才听不懂我在讲吗？
你刚才字太小了，看不见，
那你为什么不叫我放大一点？
大家都没有说。
那
下次会的。
下次啊，OK。所以你看，我叫你用 B 是什么？B 是这一个 ，OK。所以你要证这一个东西是一个 tautology， 你要先把这一个写成这个形式，那你就知道它是一个 tautology。OK。所以意思说你要把这个东西写成长成这样的东西。OK。所以怎么写呢？把这个当做 x， 把这个当做 t， 然后要把这个东西写成 not t implies not x。OK， 说你看这个 x 这个 t 啊 ，s t s t s t， 然后这一边呢变成 not x， not t implies not x， 然后怎么写呢？就在这边变了。OK， 可以吗？ OK。
3A 不会做还是听不懂
3A 不会做，听不懂。
3A 就是数列啊。
哦。
这什么字？
它不是用 induction。
这啥字啊？
Wrong sequence picking，
选的不对，这次取的不对是吧？
不要插队啊！
我等会儿来问。我只问一下这个字，什么意思？中文翻译一下。
什么 sequence 不对啊？就是有一个排列不太对，
有一个排列不，
但是我忘记了，我要看一下，我要重看一下。来 ，OK， 啊 ，OK，
这个weird是什么意思
？OK， 什么叫对？放进去，放去哪里？
就放进去那个那个叫什么东西集合里。
subset 啊？为什么不行？OK， 然后你这样子 2A 放进去啊，我这样子看你的答案，我是不知道为什么对啊，我是看到你同学写了过后，我才知道为什么这个东西是成立的。所以你知道为什么这个东西成立的？
什么意思？我不知道什么意思。
就是为什么你写了这个，你就能够算这个？你知道为什么吗？
是不是2乘2乘2有 n 个？
为什么不写出来？
那
你以为你跟我讲这个，我全部自己推出来啊？我自己算的。
那对
对不对？这题有几分？4分，对不对？我给你1半哦。因为你如果告诉我 ，OK， 第一个你没有写很好，铺也铺哪里？第二，你没有告诉我铺了这些过后乘出来的东西是2，就这样吧。
那我这样写了，就是我用它那个选的。
等一下，你还有问题吗？
我有，这不是 n element 吗？这不 2 option 吗？那不就？
我知道啊，但是你叫我自己算啊。
不用写也看得出啊。
要写，怎么写？我看一下。Every set has。OK， 你要这样子证的话，这样你要证这个为什么是对的？我们没有算过啊。
我自己算了。
我知道你自己算过，对，你要写出来。
那可是那这样应该也有分，怎么会1分没有吧？我至少写了呀。
对，老师我也写了，我写了一页 A4 纸，才给1分。
等一下，我先看一下你写的什么先。首先这个不知道什么，我们没有define
对，
OK， 然后这个我不相信，我不知道为什么不对。
那就是没有算在上面，就没办法。
没办法，我也不知道。然后
为什么教科书上了？
就是对啊，是教科书
我感觉没有啊，我们的教科书没有。我觉得高中有没有证过给你？还是他？
证过。
你们证过。
我们的时候就证了。
这样你应该要写出来。
好吧。
因为我们班没有证过嘛。然后我好像没有给人这个分啊，人家写这个我也没有给分。这个没有给分，这个我没有给分。
就是好吧。
对。
那我这道题我能不能给你解释一下我为什么要这样算？那你说。
OK。 为什么是不能给我看啥给那人来？
在那个卡片上面的那个 presentation。
可以，你们还早呢吧？不要。不知道。
我们什么时候开？
你在干嘛？可以解释一下。好像很多东西在里面，但是你没有把它表达出来。
就是它单调递增，它就不可能说它同一个 x 有同一个结果吧？
没有错，这个是我们要说的，我们想要，
这个意思吗？
但是你没有，
已经转了。
你没有 explain 啊，就像刚才那个，你就告诉我，
你确定
它只有进跟不进嘛 ？OK， 它算出来就是2，你就没有那个步骤，你没有那个步骤啊，没有，我有给你分啊，你没有那个步骤，你步骤就是我给的那个步骤。
这个问号是
有没有问过
啊？这个问号就是不能够直接这样子下来，不能够直接，不可以啊。
哦，要不要写什么？
啊，
我研究生吗？
肯定啊。
就是像我们在班上的话，我们会用那个什么 root 的方法，记得吗？
早赚钱。
就是我们不可以直接取这个 square root， 不可以直接。OK， 比如说这个，这个的话不代表这个啊。
那是因为它不是平。
我这么厉害。
对呀，但是
四方啊。
但是四方为什么能够成立呢？因为它其实它就是一个 straight line，而且 one to one 才成立。
新西兰还有。
哦。啊。我还要证明它是什么。
哦，那就是我们要证的东西，其实。
哦。
对不对？不能够用正好啊。
你先问，你们俩。
或者它 invertible， 或者
你会证吗
？OK。啊，一样啊，你跟他一样。
还有，那就
我已经给到，这个满分3分了。
他已经给你很多了。
呀，所以我们才在班上，我们才要经过这样多步骤啊，我们不可以直接这样子。
我给你解释，我了解你。
对啊，对啊。这个我们不知道它的 GCD n 和5是1，所以我们可以直接用 a 的 p
这成绩超过70的都标上了，
就是逆圆会不存在它的，那为什么？
啊，就是，哎，刚才我不是解释这题哎，我听不懂啊。
就比如这个 n 取10的时候，你那个就不成立。
哎，我解释的时候听不懂。
n 取10这个它就不成立，
就是因为它的 GCD 这个n 跟这个一定要是1，你才可以用这个 p 减1。
我惊讶的是因为，
不然的话你不可以用 a 和 p 的。
就是在这里是标在前面，
这个一定是太少了点。
全部人都是这样。
但是我看只写一行这个的也给了1分，那为什么会这样？
什么？这一行是因为你只要会算这个总的。
不是，这一题只写一行就给1分，为什么我写这么多还是1分？辛苦分再来1分。
哎。
真的是
是不是辛苦分？
不行，
写这么累，这思路都差不多对了，是不是啊？
真的，下期直接用中国来。
跟你讲，因为我知道题是怎么算的，
可以，
它不是假设说一个
，OK， 来，
今天找你就是丫丫，可以。
一共 x 的这个，然后呢，它 x 除以3与1除以4与2除以5与1，然后3、4、5的公倍是60。然后呢，这个就是它3和4
你又不回国，你
的3和4的最小公倍数除以5与1是36。
对，高数也就是这样。
然后呢，然后再乘以它这边是与1嘛，就乘1。然后呢，那个3和5的最小公倍数除以4。
最小公倍数什么 ？lowest multiple
啊
？lowest multiple
啊呀。
那为什么要看那个呢？
就是我想想怎么说，就是
怎么看那个？
可能因子数量不一样。
哎，没有哦，这个OK，
数量
看那个。
然后是我先讲完吧。然后是15乘以2，就相当于是15除以4与1，然后它有2个余数，它这边余2嘛，所以要乘2。然后这边是除以 乘5的公倍数是40，然后40除以3。
5是20啊。
我想，它是20嘛，它确实，它最小公倍数是20，但是20除以3余2，但是它这里的余数是1，所以要用40除以3余1。
对，为什么？为什么这整个东西合起来过后会符合这3个条件？
因为这里是有一个余3的，然后这里加起来又有一个余2的，然后这里又有一个余1的，然后这又是它们的公倍数，就相减，所以就会是满足这个条件。所以你只要看它这个 n 取整数的时候就可以了。然后，
所以你这个步骤哪里来？
这个是我自己
当场讲啊。
对，
当场讲的。
当场的之前学的。
在哪里学的？
就是在网上学的。
在网上。
网上看那个孙子定理的时候学的。
OK。
那可以加分的。
对。如果你要做这种事情，下一次不是
要解释一下。
你解释，我教你怎么解释。你怎么解释？你就是把这个东西放进这3个里面给我看就可以。呀。
就是去证明它满足这个条件。
对。可以吗？
好，来吧。
很快。
可以。
29 OK 啊。没事。哦，这里可以 OK 好。喂，就是
这个
Yep。
这个我已经我想到他要证了那个 induction
Yes。
但是没有分。
对，没有。
对，但后面写的不太对。
后面写的不太对。
对，但是已经就是这里有写他要证那个用 induction 证，我这个可以1分。
你这个可以。
对。他那个题就
我只要我觉得。
我也只求加2分。
我只要我觉得。
那个题他其实你的答案也是没有写那个计算过程，只是写了为什么会。
为什么会那样？就是我计算过程。
但是就是我看都是用 induction 证。
我知道。
对 ，D 那个列 DK。
我看应该没有。
OK 好，我给你1分是你，对，你要用 induction proof， 然后你的 inductive hypothesis 你不要再写了，好吧？对，行。
好，有1分，没有还写。
OK。
还要算哪？
第几？已经算了的。
不是，你还要找他问哪个？
第7个。
要问好多。
这个是243海约。哎，好。
走了。
是这个题。
Yeah。
他只要找一个反例就可以证明它不是有效的。对，然后反例就是当这个 C， 这个
眼熟。
这个
这个就是
然后它是成立的话，
看课件，
其实这个才是对的，然后这个也是对的，然后就等一下。假设这个是错的。对，这个是错的，那这个就是对的，然后这个也是对的，但是这个的话它就
我这个结果错了。
什么？你要说什么？
哦，这个字
没有，你现在只要跟我解释为什么那个 argument 不给力就可以，就为什么这个不原因。
其实这个为什么不成立？
啊。我不懂。
就是这个就是其实它不成立。就是说
为什么有这个情况发生？我不知道。
就是说假设一个就是 S 成立 C 不成立，这个就是说它是矛盾的嘛。S 它成立的时候 C 不成立的时候，这个也是成立的。
那为什么这个情况会有呢？就为什么会有这个情况出现呢？你讲如果这个情况出现的话，这个就不成立了，对不对？但是问题是为什么这个情况会有？对呀。
没听懂。
就像你刚才讲的嘛，就给一个反例嘛。 为什么这个反例存在？
那要怎么搞？
那怎么搞呢？
嗯
我们的搞法就是这两个没关系，
这两个没关系。
就是C implies x 和 not C implies not x 是没有关系的。我们在班上不是每次说吗？这两个没关系。我举个例子，